talking about it. And then upstream river discharge will come from hydrological models, river flow models, river discharge data real-time available, and strong interfaces with the ocean circulation models where wave predictions, sea surface height predictions, tidal anomalies will go as boundary condition, wave model that will be coupled with storm surge whenever cyclones are there, and river model interface is always there. Local rainfall has to be taken into consideration, and all this will be a inundation model, and then actions for decision support have to emerge. So this is called coastal inundation forecast demonstration, forecast service and early warning system, CIFEWS. So this is advocated by WMO now for since the last Congress held last month only. So whole countries will be working on building this early warning system, and let us see how India is positioned to build this service. So it is a service envisaged to be integrated with IOC's tsunami warning system, in which already INCOIS is taking a lead role and is a major service provider. And then on the ocean circulation modeling, tidal wave models and tidal models, tidal predictions and coastal sea level height anomalies, all that things are already operational in INCOIS. And ocean forecast system is there, OFS. And what we need to build is link the estuarine area inflows, backwater effects, and other coastal inflows and the upstream inflows got to be integrated into this. So in bits and pieces, atmosphere, ocean, river modeling chain got to be integrated. In local scale, we have flows in cities. Otherwise, in rest of the country, we have something called flash flood guidance system. It is a sort of rainfall runoff modeling system. This is operational for the last 3 years. So we have in disintegrated mode, several components are already operational. So we need to build this CIFEWS like tsunami warning system. I feel that the kind of preparation India has already done. So we will be in the first group of countries to build this coastal inundation forecast early warning system. So this is what I think Ministry of Earth Sciences and all related institutions need to build in coming years. Maybe 2-3 years it should be possible. Thank you.
Thank you, Dr. Ramesh. Any comments? So he's.
Just wanted to say that this inundation modeling, especially coastal, is very important. But one thing which is we are still missing is the high resolution topography within let us say up to 5 kilometers from coast. That data is very much required. Otherwise,
that has to come from your.
No, that is what is the need
yes,
of this thing. And then this time in Biparajaya cyclone, many of this storm surge and inundation failed because we are not integrating the tidal component.
Yes.
Wherever there is a tidal surge is very high, like in case of Gulf of Kutch,
yes,
where the tidal range is very high, all these models are failing.
No, we have not dynamically included tidal surge interaction actually.
Into the model.
Model.
So this was the lacuna which was identified this time. So I think we need to work towards.
We have models, only computing was required for tide surge interaction dynamically. So now that should become possible. That should be possible.
Yeah. Okay, any other question? Okay, so thank you, Dr. Ramesh. And now we'll move on to the next presentation by Dr. Ramesh.
Thank you, Chairman. Also, I congratulate NCCR for the 25th year, Dr. BRS is here, Dr. Ramramurthy, I could see also Dr. Sampath for completing the 25 years. I just want to give a different perspective in the whole, because we have been talking about a lot of science, and I thought being earlier with the Ministry of Environment for us, I thought science and policy linkage, how one could link the science which we already know and how we could take it up further. So, I mean, the main idea here, already we have been told about the 7,500 crores. I just wanted to emphasize here that the coastal, we have about 78 districts of coast, which has a population of 170 million. When you take the entire 9 states and union territory together, which is about 560 million. And other thing is we are trying to reconcile the number of islands. Still, the Ministry of Home Affairs has not yet come to a conclusion. Right now, we are coming to the figure of the 1,382 islands. So this is the figure which we have right now. In terms of looking at now the entire ecosystem, you look at the ecosystem-based approach. There are 3 cycles of sustainability here. The one is in the oceans and seas, where you can see the ocean resources on one circle. If you are keeping it, the ocean resources, conservation, and then equally utilizing it without too much of extraction due to the man and society, and this cycle will continue. But because of the climate change, the pollution and other aspects, including the marine litter and many other aspects, so we are completely changing the cycle, and which causes a lot of interruptions. So that ecosystem-based approach is what we are looking at in the whole scenario. So the IPCC recent report, the science is very clear that the climate change is happening. There is no climate critics which say that no, nothing is happening, that we can see every day now. And we have the evidence from the severe droughts to the heat waves to the coastal flooding. Now the report which shows that during the pre-industrial time to now is about 1.1 degree we have increased. I think in the Indian Ocean, maybe correct me wrong, it is 1.2 degrees, slightly higher, even take the whole world as together. So 1.2 degrees, and maybe by 2040, it is also said we will be reaching this 1.5 degrees centigrade. This is what the prediction which is going to happen. So unless we do something, some major interventions. There are huge threats in terms of the warming. The ocean becomes more acidic, acidification, and so many other issues in terms of the entire ocean science. One of the recent report, this is from the Nature, which they have come up with, that if you reach this 1.5 degrees, we are going to completely the coral ecosystem, which already, as per the Australian Great Barrier Reef, nearly 25% of the reef is dead. So I think if you reach the 1.5 degrees, that we are going to lose the most of this ecosystem. So that is one of the major threatening aspect. That is why in the G20 in Saudi Arabia, we have already formed a coral platform. This is called CORDAP, and we are trying to put more money in terms of the international research on the coral reef ecosystems. And the sea level rise already the chairman also talked about, and we know that the major point which I like to emphasize on the Sundarban region, where we have not only the sea level rise, and we do have the subsidence, which has a huge impact on the Ganges Delta region. From the morning we have been talking about the coastal erosion. I just want to.
Do we have observation of subsidence all along the coast?
No, we have more data on the Bangladesh side because of some international projects. For the Indian sides, we have.
We don't have much data, really.
Indian side, we have very few data points, whereas in the ONGC and few other points.
Kolkata city,
Yeah.
almost Kolkata and Hooghly that is subsiding actually. So there are observations from interferometric SAR and other observations. So that region is under subsidence in our part.
But subsidence is not being talked by many people.
Yeah, it's not being talked, but it's a real problem in many Indian cities. Somewhere it is linked to the groundwater extraction like Chandigarh, Rajkot, many other cities. Calcutta is because of the deltaic environment. And of course, as he is talking, Bangladesh part is also because of the loading of the the sea level water itself, loading itself produces some subsidence of the land. Order of magnitude is of the order of centimeter scale or so per year, but actually if it continues, yes, very high in certain regions. So people start seeing cracks in their building overnight, So that kind of issues are happening now at many places.
Chamoli was the subsidence?
Chamoli is a subsidence, but that is very high order, sir. It is now, we have calculated, it is of the order of around 23 centimeters per year kind of thing. 23 millimeter per per year is the rate.
I think millimeters, sir, not
Yeah.
not centimeter.
23 millimeter per year, I corrected that. So that is the rate, but from December of 2022 to March of 2023, within that period, you know, the sudden subsidence which has happened at the certain location was of the order of around 60 centimeters or so also at certain locations. Within Chamoli, within that Joshimath area.
That is why even the erosion is very high there.
Yeah.
That coastal erosion part is.
So, subsidence, how it is measured? Is altimeter?
It is measured using synthetic aperture radar by making phase measurement. It is a technique called interferometric technique, radar interferometric.
Simple altimeter is not.
No, it will not work.
So this, we also looked at with the Survey of India the area which is the hazard line, both erosion and the flood line. So it's approximately about 78,000 square kilometer of hazard line is mapped. You could see here for all the coastal districts. So here, what you could also see that the area of inundation. So there are certain areas which you could see how much of water level in 1 in 100-year flood level, how much of water can go inside. The percentage of inundation, we can also try to do some sort of color coding. So where there is more of red, you can see more than 36% of inundation. So places like Mumbai and the West Bengal part, and also part of Kerala, where we can see the percent of inundation is quite high. And apart from that, the islands, for example, the island is a major concern. So the internationally also, when you look at some of the islands, even the Maldives and many of these islands, the people have been, even they have to think of moving those people. In Kabati, that about 5,000, they bought some land in Fiji Island, and they had to move the people to the other lands because of the sea level rise. This is just an example of the Sagar Island. We tried to map over a period of, say, 100 years, see how much of land which is being now completely because of the rise. You can see we are losing so much of land here. And this is the another thing which is of worrying. Maybe the satellite imageries can also show that in the last July 12th Nature journal, they come up with, I think the MIT, Stephen has come up with this type of modeling, and where it says that nearly half of the ocean has changed color in just 2 decades. And this is really a very big deal. I mean, in terms of changing the color, I think I don't know whether we are able to observe the carbon which you are talking about. The ocean is going to be the major, I mean, we are thinking as a major sink. And is it going to happen, and what is happened to the plankton community which is going to have? It's a very major thing which really worries me. And the other aspect, I think I have seen also that the ecosystem goods and services, I think when you go to the policy makers, I think they will be more interested in looking at some of the ecosystems and how much it provides in terms of save these ecosystems. And I think this nature communication again has come up with that they said that a multi-million-dollar ecosystem is there beneath the waves. Because of the kelp and the seagrass, they said nearly $500 billion per year of services it provides, which is a very good calculation they made. I think the seagrass, which plays a very important role in terms of ecosystem services, and that is one thing which we should be able to look at here. So what are the major takeaways? We know the science that it is going to increase the temperature from 1.5 degrees in the next 2040. And the major things what you are thinking about is the ocean, the forest and soil. And the ocean, we already know that it is not, the effectiveness of the carbon absorption is as we thought it is there. So it is reduced to a large extent. Similarly, the forests also, it is reduced to a large extent. And the soil, which is also another important aspect, is very much worrying because we have been using the fertilizer over a period of time, more and more fertilizer. With the fertility of the soil, if you look at during the soil health, during the last 20, 30 years, it has decreased so much. And the food production, I think is going to be more and more degraded land. We are coming up with more degraded land. So these three major sinks which you think where the carbon is going to take as a sink is not really going to happen. And this is one of the major worrisome which we have to see. We think these three things will take about 50% of the carbon. That is what we are thinking. But I think it is going to diminish very fast. And this has already reached the tipping point. So I think that is one thing which we have to look at. The other alternative, being a coastal person, we have to now look at the conservation aspect, look at how the mangrove, the coral reef, the seagrass, and the salt marsh has to be, first of all, keep those ecosystem healthy so that it is at least 10 times more effective than the tropical forests in terms of taking the greenhouse gas absorption. So I think these three ecosystems plays an important role, and we have to try to increase the marine protected areas so that the resources can be much more enhanced, so that we will be able to at least take up, on a global scale, it is predicted, it has been observed, nearly 33 billion tons of carbon can be taken up by this ecosystem alone, which is about 1/3 of the carbon which we are emitting. So then the second aspect is we have to look at some sort of a transformational action. Like the major source we are talking about here is about the energy, the industry, and the agriculture, and these are all the major sectors which you have to do some sort of a transformational aspect. For example, transportation. So we are already in a very big this thing on the EV, on the electrical vehicles, but this is not enough. What we are doing is some sort of a transitional, but it has to be a transformative action. So doing something, like few vehicles here and there, few green, this thing will not going to help, because the time what we have is very short. We have to do something very fast and very quickly. And similarly, that's energy. I think our energy, solar energy is really increased. I guess it's about 60 gigawatt right now we are producing. So we have to look at the offshore wind energy. For example, China and many other countries, Europe as well as US, offshore wind energy potential is much high. I think right now we are only looking at the experimental stage, and maybe we may take about 10 years to come up with more on the offshore wind energy, which has a huge potential in India as well. So these are all some of the things which right now the incremental is not efficient, and we have to look at transformative action in order to look at the climate change and the coastal flooding. Thank you so much.
Mostly on the climate change aspects on coastal flooding, and he was suggesting that we should have a more in-depth action to reduce the carbon dioxide emission. Oh, the net zero emission being talked by many people now, and there are a lot of options now. India is planning to have a green hydrogen option also now. So,
highlight that net zero is the buzzword everybody is talking. So like as US and Europe, everybody agreed for 2050 net zero. China said 2060, and we said about 2070. But I think even many places we already started looking at the net zero. For example, Tamil Nadu, we have already started few places, like they started looking at how to bring the net zero from different sectors. So that type of actions has to be taken up in a very large scale.
okay. So any questions to him, Dr. Ramesh? Yes, Samson.
You have mentioned that there is a degradation of coral reef system of 26% by which of increasing temperature 1.5 degrees. What do you think about the acidification? Is there any role of acidification in degradation of coral reefs?
Yeah, I think acidification. No, that our data on acidification is very limited. But acidification, because we know the CO2 is increasing, as we know our CO2 concentration right now is about 412 ppm. It was about 320 ppm in 1958. So we have increased around 100 ppm in the last, say, 70, 80 years. So that means that the ocean is trying to absorb, and the pH has been reducing. So that has a huge impact on the ocean acidification, has a huge impact on the coral reef. And also, its observation is already made. Many places there have been observation. The NOAA data is there. And here also, I think CMLRE is doing some observation. I don't know, they're here. And even NIVO is doing some of these observations.
One question about the change in sea color, ocean color. Is it from IRS-P4 or from which satellite the data is that?
No, this is actually, I got it from the Nature paper. And it is from the MIT. I have to look at the source of the data.
Because our ocean side data is much more, resolution-wise is much better.
This is just very 10 days before it was published.
Okay.
It catched my eyes. I thought I can just put it and highlight that point.
Very well.
Okay, so there are no more questions, and we'll go to the next presentation by Dr. Balachandran.
Thank you, Chairman. And at the outset, congratulations to NCCR. Since the last I am making presentation, to always difficult because most of the things are already talked by everybody. It will be a repetition only. But so I will quickly move on that one. Most of the coastal inundation hazards already listed there due to sea level rise and storm surge and inundation. Like this, we know that what are the things happen due to which, how the decrease of the sea, ice sheets and all this mass, that leads to the changes that already known it one. SST anomalies increasing that one, and heavy precipitation increase noted. And as Rajendra sir already pointed out, the trends in tropical cyclones, that also have inhomogeneous different type of things. We have one side BOB decreasing, and at the same time Arabian Sea increase is seen there. But most of the models indicating that though the number will decrease, they will be very severe. So moving average is also showing trend. And sea level rise implications, most of the things already, because I have to see that all the things are, Ramesh are already brought out everything. So the rate of change is more accelerated recent times, 4.5 millimeter per year, which was, if you consider different segments of the data, that shows that recent times that is increase is more. And this also, that spatially variation will, that sea level rise is there, but there is inhomogeneous things. That how the dynamics will change such type of inhomogeneous things. And what is going to happen scenario, that is also, we are seeing this under different scenarios. Most of the things are in positive direction only. Maybe the magnitude will be different according to their uncertainty. Projections also show that there will be increase in the storm surge due to this one. Sectoral impacts will be there. And this shows that we should have an action plan for the hazard and vulnerability, risk and exposure, all the things we have to see into consideration that one. So based on these guidelines already given, implementation of the coastal inundation forecasting, early warning system, WMO already has brought out. Major thing is, apart from the technical consideration, other things, the WMO has initiated coastal inundation forecasting initiative and flash flood guidance system and severe weather forecasting system. So basically, the broad outline, they say that steps which are to be introduced, undertaking the national level risk assessment has to be carried out, and the stakeholders meeting has to be conducted, understanding the technical assessment, communication, end-to-end communication should be there. So they listed out the things, most of the things are listed out. And so with the 4 components of the multi-hazard early warning system, observation as well as the risk assessment and warning dissemination and preparedness, all these things level, different components and MOES, they are attempting like storm surge model, tidal models, wave models, high flows, all the things are discussed here. So recently flood forecasting is also CWC that we are doing it also. Now flash flood conditions also there. Now the main thing is, to the point is what the data is telling, their existing data is past data, and what the model is projecting, and what is the to be done action plan. These are the 3 ways we are approaching. When the current data and what is past data is saying, at times some uncertainties are also there in the data also. And model prediction, when it comes to the model prediction, there also we are talking about the uncertainties models. because which type of physics, which type of model assumptions are being made, that projection is also made. Now, basically, quality controlled data set, one of the point is there. Now, when it seems, from my point of view, developing science is very relatively easy. You can do it, but the data collection is the biggest point. Being in an operational organization, I find that everybody talks about the quality controlled data set. That point is the very, very difficult now. In fact, relatively, if you see that more scientists are there, but the maintenance part of the people are very, very less. When you come to the, another point is data collection points. We say that now, I read one article in the, it has in the Journal of Med Society Japan, 1,200, about 60% of the ARGs are in the top of the buildings only, in Japan, Tokyo itself, because cities will be like that only. If you want to have a WMO type of exposure condition, particularly for no cities, we all know that you won't get that type of exposure. And it has been seen that studies have shown that top of the building, center part of the building, if you measure, it depends, variation will be very little, unless otherwise there's some kind of wind variation is there. So to what level uncertainty you are ready to accept? If you say that no building should be there 3 times the distance, that type of things there, as a city is going, you won't get such type of exposure in future. So unless otherwise that, what kind of quality set of data, what kind of threshold we are going to put for the condition, it's very difficult to get the things. Because when you have heterogeneous type of data sets, very difficult to ensure the quality also. Sometimes some of the rain gauges are kept inside the field, sugarcane field, where the leaves, from the leaves, the waters are falling inside that one. So it's very difficult to ensure the quality control data because of the science models. With the technology and the computers, you can develop models very quickly. But getting the quality data set is the major aspect. That has to be ensured. Unless that data set is there, your validation as well as the further things also to be, it will be a question or something. Another thing is the model point of view. Just I want to, because we are attempting here the cities like Kolkata or Chennai. When you develop the models, how much it is dynamic to take into consideration of the recent changes which are like storms, drain mechanisms, they are doing it. Because city is not like that which was earlier. After 2015, the flood system, every year they are changing the landscape of the city itself. So how much that is reflected in your model? If it is not, because all these things are also connected with the streams and it is connected to this river which is flowing through the city only. So finally, if you give that one, it is not only your rain, but collected water from different areas and channel, it is put into that one. That results in the flooding things also there. So that has to be considered. These are the 2 things. So on these, taking with this one, action plan is the another one that we know that is the third part. It's a administrative point of view. But basically, addressing the issue, the quality data set obtained, that is the major thing nowadays. And even the radar is also there, but we are finding difficulty that the validation of the radar set also still not attempted. While the other directions works are being made, but how to utilize that direction data in the rainfall point of things, realization of the rain. But radar data need not everything shown there, it did not be at the ground level also. It is showing only the cloud level. So what are how much that has to be utilized? That has to be also attempted. With these points, I want to close that.
Rajendra, you have, anybody has some comments or questions?
Just wanted to make this point. See, over the last 125 or 145 years, IMD's strength was data. And we claim that IMD data can be, and today a DG IMD or DDG IMD is telling all the doubts about the data. So it's really amped up. Because all along, IMD was supposed to, and you see, you have to change the standards. For example, suppose your, let us say, AGS or your rain gauge was putting in some condition. If that condition is not applicable, change the standards. But that much dynamism you have to have in IMD. So if you start raising doubt, whole community will go, in doubts only. Whole atmosphere community will be in doubts. Because all along our strength was this. So I'm surprised.
Sir,
Sir, actually the data, what now we are getting, AWS data, what he mentioned, apart from IMD is very little, many state governments, many agencies are putting the AWS data, the other type of things, which are not following the standard.
Why they are
practices.
putting?
For different purposes they are putting.
Why they are putting?
So they are putting because IMD is not able to put.
Yeah, that's what I'm trying to say. See, I have gone through this process. They are putting because IMD is not doing their job. You can record it if you like. Why should anyone invest money? Because we are not doing our job. IMD is not doing its job.
See, IMD is not able to, it's not doing the job, it's not correct, but IMD is not able to do the job.
Sir,
There are two things.
I
There are
differ
two
the
things.
point.
There are two things, sir. One is the money required for putting these observations is very important. So IMD is not given adequate amount of money for putting all the engages, number one. Number two is installation of engages is a tedious job. IMD is an operational office, IMD don't have that kind of infrastructure. So that's why IMD said that if you want to put, you put. But then you follow the standard. You could, see, my suggestion is IMD is, of course, is responsible for putting meteorological observation. But that does not mean that all the observation which people are planning, IMD should be given a responsibility. IMD is not only putting observation, they have a lot of other responsibility. If IMD can do it, well and good. But IMD did not do. IMD did not do it. For some private priorities, the private priorities have come because IMD is not able to do. Yeah. Because state agriculture ministry wants every taluka, every district, they want an observatory so that the insurance companies and all can use it. IMD said we cannot give, we cannot do it. It's almost impossible for IMD in the given circumstances. For example, funding, people are required. So that's why they said if you want to do, you do. That's kind of thing. IMD was not avoiding the work, but
it is not.
It's avoiding. If you say, okay, see today, if you say anyone can put that, you put your happily, so they will not follow your standard. See, either you impose a kind of a quality system on them. If you are not able to do that also, so then it is a failure of the system.
Let me compliment that one. Sir, 99 to 2002, I was in the instrument division. I was installing, that time it is called DCP.
I have seen your instrumentation.
Yes, sir.
Let me tell you, 2005 when I came, your DG told me that you have got a best instrumentation in Pune. I went there. That instrumentation lab was worse than any BE college. Even oscilloscope was not there in that lab. I have gone through your instrumentation, all the hierarchy much senior to you. I have talked to them. It was so pathetic.
Sir, because I am working, I am not saying that. Main problem where lies the problem. Because everybody wants to go work on this seat in AC room and working with the data. The people are not ready to go for the field. You have to distribute the field. It is a manpower because I cannot, beyond certain limit, I cannot this one. We are deviating something. Yeah, only the scientific aspect only I told.
Yeah, we are more worried about coastal flooding.
Coastal flooding.
It may come tomorrow
But,
also.
Yes.
So we need to worry about that.
Very easy to, sir. Actually, I want to say that I know state government party also I have seen. In Tamil Nadu state government, recently, if you go there, 29 centimeter was July 13th. There was a record at Vidupuram, one station record, two stations recorded 28 to 29 centimeters. When we had a doubt, collector went there, he said that it was verified, it is like that only they are saying. But when it comes there, our one station, we don't have observation there, and only one AWS that is also not working now, there is other problem. Then I went to Tamil Nadu State Agriculture Department, which is having 15 stations there, none of them are not working. None of them are not working. If I can open now, you see there, we have PWD having maintenance of AWS, water department is having AWS, multi-organizations are maintained. Only when it really do it, then will you understand, because it is very easy to do sometimes working with the data, but to collect the data is very difficult.
Sir,
because we have to.
Can I intervene?
Go there.
Can I say something?
Instrument.
In context what Professor Goel said and what Balaji. Sir, there is guidelines, BIS guidelines IS 5225, which is existing for setting up rain gauges in this country. It is not the duty of the IMD or the MOES to state. It is the governments and other, whoever is installing has to follow the guidelines.
All people give the same excuse. There's nothing new in it. Okay? You know very well that those systems don't work. Tell me which state government system works properly today. If you leave it to them, you will face the same thing. So I gave the example in the morning in the context of road making. And we know that with what consideration roads are made today. Some roads are made to actually break down within 6 months so that every year they can remake it because there's a commission every year. So we know all that. Still you will leave it to them. So obviously you will get into the same result.
Sir, but they have to listen, sir. It is not the question of leaving. It is something like putting up seismological instrument. NCS puts up as per the standard. I'm just coming because I'm a seismologist. And NGR, but the others don't follow it. We are not the regulators, sir. They can only propose. They can ask for the instrumentation. But the mindset should change and the outreach has to go. But it is not just a single ministry where it is going to say all the instruments are going to be of this.
See, we need more than 10,000 ARGs in India. Do you think that IMD is able to do, will be able to do it? Impossible. So that's why we told the state government, we requested the concerned state government, you please take responsibility. But IMD has a responsibility of, for example, calibrating the machine and checking the instruments once in a while. That IMD has a responsibility. IMD don't have the money, funds, first of all. That's the problem. So we told the government to do it.
But it is not clear. Lot of rules has to be changed. We have to hold up certain old rules. Very difficult. It looks like we cannot handshake with the folded fist.
It's all okay, Rajendra, I think, yeah.
Because I'm in the administration now, I feel it. Otherwise, I also deal with
but then this forum is not meant to discuss the internal issues of IMD. So you may have your own problems, but here we came to discuss coastal flooding. If somebody has any more points to discuss about coastal.
You have to close now because we have to start another one.
Okay. So
and
thank you very much, all the panel members.
There's no tea break. Tea will be served here.
So thank you very much. Thank you very much, all. So somebody has noted down what we discussed.
I thank the chair, co-chair and all the panelist members for the thoughtful discussion and valuable insights shared. The suggestions provided by everyone will be noted and considered for the future work. I now request Dr. Anita Gera to felicitate Dr. V.S. Prasad, Director, NCMR WF.
I think we will avoid this kind of formalities and we'll go ahead. Sir, Goel sir, you can come here. Goel sir, you can come.
Dr. Swadhin Behera, Director, Jamstec. Dr. K.J. Ramesh, former DG IMD. Dr. R. Ramesh, former Director, NCSCM, Chennai. Dr. S. Balachandran, DDG RMC, Chennai. Thank you, ma'am. With this, we conclude our session, and I request everyone to gather at Manthan Hall for high tea. Our next there's no idea.
Yeah, we'll start. No break.
No break.
Tea will be served here.
Fine. No, they told they cannot serve it here. So that's the reason we thought of
He came here, he asked me, I told him you bring, he says bringing your person. He came and asked me.
Then okay,
You just check it. He asked me.
No, I'll keep the things and we'll start.
Because otherwise, if it goes, I have to leave by 5:15, positively. I'll leave it to you after 5:15.
Okay.
Okay. Vijay Kumar? Vijay?
The next session on blue economy and ocean accounting will be starting soon.
Come along.
I request everyone to settle down. Tea will be served here. Thank you.
Vijay has come. So Justin, yeah. Dr. Sushil Kumar. Dr. Mohanty. Vijay Kumar. Dr. Sushil Kumar. Two. Yeah, we start. Tea will come here. Tea will come here.
Okay, I'll just pop out to the restrooms.
Yeah. So we'll, we are already late by about 20 minutes and so we'll try to make up this time and I need to leave 5:15, so I would request our co-chair, Professor Mohanty, to take over. What we want to do is the following. Each panelist, you please take 5 to 7 minutes and give the gist of your observations, recommendations, and findings. And I would request further, if you can summarize your so-called recommendations into a para and give it to our organizers. I will see who is organizing the session. And so that we will try to make a kind of a consolidated recommendations from here. So I'll just check up whom should you send the, which email. Because ultimately, this is an important topic. And there should be some recommendations to the Ministry of Science, what they need to do. And that should come from this consensus. And not only the panelists. My suggestion is, any member, please feel free how this process of so-called blue economy for the country can be taken further. Now, what blue economy mean is basically, you can say, generating wealth in a sustainable manner. It's not just generating wealth, because wealth can be generated in unsustainable manner also. That is not the purpose of blue economy, but it should be sustainable. Also, as we know that our population is growing, our dependence on the ocean is increasing or will increase. People are even talking about living into the ocean. So when we are talking of that kind of scenario, how country should prepare itself in next, let us say, a decade or maybe 2 decades, a kind of a thinking process that is going on. And all of you are well-read, you people read everything. So whatever thought in your mind, if you put that, then what we'll do is, in next 1 week, we'll try to consolidate those thoughts and try to put in terms of some kind of a profile, okay, this is what the country needs to do. So if that is acceptable, I'm not going to make any presentation. My only main point is that we really need to have a sustainable ocean, a sustainable coast, and a sustainable economy from the ocean. So how we can do it? Many areas are there in this. Our country has not invested enough. For example, when we are talking about deep sea fishing, our presence is very little. When we are talking of, let's say, getting either food or medicines from krill, our presence is very little. So there are many areas like that. Even in terms of generating, let's say, offshore power, wind power, we have done very little in that area. So there are many thoughts like that. I'm just trying to give you what are the possibilities. So with that, please give your thoughts, and then we would like to consolidate that. So with this, I would. Let me come in. Okay. So we will. Dr. Monty would like to make a comment, please.
Yeah.
Go ahead.
When we talk about blue economy, accounting, why blue economy is important? Blue economy is again a part of GDP estimation. So the relevance of blue economy is that this is the fastest segment which grows much faster than your general GDP. And that is the most attractive part, and it is done in the most sustainable way. So GDP accounting is very important because most of the sectors, particularly non-traditional sectors, emerging sectors, are highly capital intensive. So accounting is very much required to identify the priority areas for further investment that could really contribute to the growth of the blue economy. That is the fundamental questions. But the whole issue is about that how to estimate it, the blue economy. That is an extremely complex procedure. So far in the world, there are only 30 to 35 countries have estimated it. As we know, every year, all countries are estimating GDP every year. And blue economy is a part of the GDP. Then why all countries are not estimating GDP for all years? Because it is a highly complex one. And that technical aspects should be undertaken by individual countries. That expertise to be developed, and it is not developed by many countries. US in 1975 started with the process with a separate classification of industry classification known as NICS. And later on, OECD also tried to brought out another classification known as NACE. But what we are doing in developing countries, we have not developed any classification as such for industry to estimate the contribution of different industries to GDP. That is the fundamental problem with us. So what we have been doing, we are trying our experiment with one UN classification known as industrial classification, known as